Yeah, thanks, Mary, for that nice introduction, and thanks that you're here today. And it's quite impressive how many topics the OSH community has to cover. Huh? So, and now I like to go back, and in the morning we had this keynote speech about AI. So some of the things you can maybe now easily follow. And I would like to give you now an insight of these challenges according to a very fundamental thing in our community is the risk assessment. And can we fulfill the risk assessments when we have to do with machine learning or with artificial intelligence in general? I will give you a short background about product safety. It is, in my view, a part of the occupational safety. I know that this is not in all countries for your organizations that you are not responsible sometimes for that, but this is a very important thing. And then I like to go to the risk assessment of AI, and I like to give you a short insight about our research approach, what we have done in BAuA, and what we like to do in this field. And we hope, of course, that we can participate with a lot of you, because it's clear from the beginning that this is a challenge which can nobody cover alone. To the background, a lot of, or you are all familiar with the criteria of human-centered work. And when you look to them, and when you, of course, you have to achieve and to cover all of these different aspects, but when you go to the basement, to that, the feasibility of work and the freedom from harm is related very much to product safety. So we have to be assured that the product, when it will enter the market, is safe. Therefore, I like to quickly go to some legal framework, which is here related to machinery and also work equipment. The most of you are very familiar with the right branch. So the most of you are working in this area that you want to have good work conditions and good work environment, and therefore we have all these, let's say, directives on the right-hand side, and this you will do and will characterize furthermore in national standards with technical specifications, with some useful informations and so on. On the left-hand side, we have the free movement of goods, and the Article 114, and for instance, one of the most important, let's say, regulations there is the Machinery Directive, and therefore we not go to our national standards or technical specifications that we do national. No, we go to the harmonized standards. That means we have to cover also that field, and we have to address that, which is, and this is the reason why I like to point it here out, sometimes in the OSH community a little bit forgotten that this is also a very important area to achieve, let's say, safe products at the end. Have a quick look in the actual Machinery Directive. In the Annex 1, General Principles, the risk assessment has to be carried out. And to make it simple, for the complete machine, for the complete system. When you now have a look to the new Machinery Directive, which is now implemented a couple of weeks ago, 2023 1230, this is placed now, this general principles, in the Annex 3, Part B, so there are some movements in this directive. Then you have, of course, to cover that also, but there are, in some other sozusagen annexes also, there is an intention also to have fully or partially self-evolving behavior you have to cover. That means, from the regulation point of view, we have to cover some machine learning aspects also within this directive. So we do not have to wait for the AI Act, where we are now in the trilogue phase, which will probably be, let's say, published then or finished at the end of the year. This is my suggestion, because when you look to the document, they are very closely together from Parliament and Commission and so on. So there is a lot of, let's say, ongoing legal developments who force us, or who force, let's say, also us to cover that. We have here the new Machinery Directive. I already mentioned the Horizontal AI Act, where you have to cover much more things than, let's say, OSH-related aspects. And we have also the Cyber Resilience Act, which makes it easy, not simpler, and make it from the point of what was mentioned also in the morning, from the security aspect. There are also a lot of things to be covered. This I will skip. Of course, the mechanical engineering sector in Europe is a very major, let's say, industry sector, very important for all of us, and that we are here talking about a lot of products which has to be covered there. Let's go to the risk assessment. Very general, have a look to the 12100, ISO 12100, where risk assessment for machinery is, let's say, is there described. We have to determine the limits of the machinery. Okay, when I said before in 2027, we have also to cover, say, self-behavior elements. Maybe this is not anymore so easy. What is really the system boundary which has to be covered? We have to identify the hazards, and then we have to estimate risk for each hazard. So we do a risk analysis, and this is part of the process, what we do there. You are all very familiar with that, and it's detailedly described in the 12100. The estimation of the risk is but something which is a challenge in terms of AI, in terms of machine learning. Because when you look to that process or to the elements of risk, we have the severity of harm and the probability aspect there. And this is at the end then, of course, risk. But what is the probability of this AI or of this machine learning elements? When I use now machine learning or AI as a word, of course, we learned in the morning there are a lot of different subgroups and different methods behind. But this is something which has to be covered somehow, because when we cannot do that, we are not able to fulfill our risk assessment. And in the morning, we learned something about trustworthy AI, and I gave you here also some information or some slides. And here you see the aspects that has to be covered. There are, for instance, robustness, reliability, resilience, fault tolerance, stability, uncertainty, and so on, and so on, and so on. There are a lot of aspects which we have to use in our, or where we have to analyze it for our risk analysis, and that makes it very complicated when we talk about this new method of machine learning, or let's say artificial intelligence in general. So what is our research approach for this topic? We believe that we need metrics and measures for the trustworthy of AI. So maybe you know that we do not have a definition for AI, and even that what we had in the morning of weak and strong is maybe not so helpful for us from the project safety point of view. So at the end, we need metrics that we can cover it. We have in the BAuA, we have set up 2 teams, one in Dortmund and one in my group in Dresden. And in Dresden, we will cover more on this aspect of the risk assessment. Of course, this is, I would say, really a starting point. And you see also for us from their specifications, we have now mathematicians, computer scientists. This is also new for us. So we are related to very, let's say, from the machinery point of view and from the machinery safety, the most of us are here engineers, and so this is also, I would say, a language problem sometimes to understand what the mathematician wants to do and what we as engineers maybe describe or understand behind that. So very interesting, this, let's say, or it's very good that we could set up this research group, and this is what, or how we like to follow. We have there to our, let's say, work, we have structured after the lifetime circle of machine learning. We believe that this is a good architecture, a good, let's say, classification for us to, let's say, do our work. And the idea of ours is, of course, that we are able to identify measures, quantitative and qualitative metrics, as a basic for the risk assessment. This is what we like to achieve, and this is also here the reason why I'm today here, while I like to open up that, and it's also to invite you to support us, or that we find, let's say, ways that we can share here our informations better in the OSH community for these new topics. We do there a lot of different things at the moment. So for instance, we do some uncertainty estimation, we have some explanation method, distribution shift detection, data augmentation strategies, test data generation, robust training. You see there where we have first results, we pointed at with a green dot, where we are more or less just at the beginning, it's yellow, and what is planned in the next future is generated with a red dot. And at the end, of course, we have to summarize this somehow to the assurance cases and to an overall risk assessment. The different use cases I will skip because I'll just check the time. So, but in the morning you heard a lot of some different use cases, some different applications where this is interesting, and we believe there are much more. And of course, never forget there can be on the work equipment side, and of course related to a product somehow where we then in the product safety. Also, this I would like to skip is some object recognition, a safeguarding for machines. At the moment, this would be only, let's say, acceptable as an assistant system, but might be in the future. Industry wants to have that because there are a lot of, let's say, benefits when you would use that by an object recognition. But what is now the problem when we see that? And you see here some of the, let's say, different, when you go to object recognition questions, you see here just some pictures, and you have the reliability here to say, to do a classification for that object. And you see here just for a normal, let's say, 32 by 32 pixel colored picture, the state space is very, very big, and you cannot really check them. We learned in the morning we have to check our, let's say, machine learning approach, but the question is when this space is so big, how we do that and how we like to achieve this. So therefore, we have some robustness, let's say, criterias. There are different evolution approaches, some statistical tests, adverse attacks, formal verification. They really run out of time. And how we measure robustness, and therefore we have some first contributions so that we can analyze this misclassification, so that we can say not anymore it's good or bad, so that we can somehow quantify it. And therefore we have done some work. And this is just an example for one of the things like robustness. Yeah, this is only gives you just a quick overview to that. We have done now some robustness metrics done by LP norm corruptions where we do that, and now I skip again to have the summary. This is what I like to share with you, is that I want to say that risk assessment is a very general and basic thing for us in this OSH community. And we all have to work now on that, because the implementation of these new techniques has to cover, let's say, fields which we are not fulfilling at the moment. And this is even on the international level the same. So we all have the same lack of knowledge and information. But when we want to use that, of course, we have to achieve that even from the legal point of view. So with that, I'd like to thank you for your attention. And sorry that I'm over time.